Hello everyone, welcome back. So this is Chandan and you are watching the learning field. And in this video, we are going to discuss the questions of CSIR NET December 2025 partial differential equation part B. So there are three questions were asked in these portions of part B of PD and total 9 marks. So we are here trying to solve the questions of these three questions and discuss each and every aspect of the questions. So let's start. And before going to start, I'll request that those who are new in my channel, please give a like to this video, share with your friends, and please subscribe the channel. So let's start. So this is the question. This is the first question. Question ID is this one. This says that consider the initial boundary value problem IVP ut plus ux is equal to 0, where ux0 equal to a to the power x and uh, u0 to equal to 1 minus sin t. Basically, this is an Cauchy problem, and the four option is given. You have to solve, and you have to just see the solution of this initial value problem. So first, given the problem is, so first we apply the Lagrange's solution of this problem. Fine. So it is given that ut plus ux this is equal to 0. Now if we see first that dx by dt by and du by. So du by 0 clearly dx by 1 and dt by 1. Du by 0 means, so first we get u equal to suppose c1 constant, and dx by dt 1 means x minus t equal to suppose c1 or c2. Now the solution is like the form what u equal to, you can write that phi equal to phi of x minus t. This is the solution of one case. Fine. Now by applying the initial that given the condition, boundary condition initial problem, which is given u x0, this is equal to exponential x, and the range of the x is 0 less x less infinity. See here, the value of t is equal to 0, fine, and x is from 0 to infinity. That means definitely here x is greater than t. So this is the first case where x is greater than t. Now if we find the solution, apply this to here, then we get exponential x is equal to phi x, right? That means after applying the initial condition, the solution becomes what, that u x t, this is equal to exponential x minus t. So this is the case one solution that we get. Fine. So for x greater than t we get. Okay. And if the range is given, so here if we see that in option C, fine, it says that for x less than t, it is the solution, but we get that for x greater than t, this is the solution. Therefore, we can discard this option. There exists a solution in xt for x greater than t, but for x greater than t, we get the solution is the form of exponential x minus t, and here it is given sine of x minus t. Therefore, we discard these things. Fine. For x greater than t, we get exponential type of solution. Here it is given that x less than t. Now, if we apply the second boundary condition which is given here, the second boundary condition is given that u0t, that is if x equal to 0 and t is greater than 0, it is given. That means what? Here the case is x is less than t. Fine. So for x is less than t, if we apply to this condition, then we get 1 minus, in this condition we get 1 minus sine of t, this is equal to phi of what? Phi of minus t, right? Phi of minus t because of x equal to 0. Therefore, what is the value of u? The value of u is u is equal to uxt. This is equal to what will be happen? 1 minus sine of c. It's for minus t, it will t. Therefore, we write here minus of x minus t. Fine. So this is 1 minus sine of t minus x, and this will hold because see here t greater than x. Okay, definitely it is t greater than x. So now for what is given here, that for t greater than 1, for t greater than 1 there exists a unique solution. This is equal to e minus this one, but there is no exponential format in this case. 1 minus sine this types of form is given. Fine. So for t less than 1, if this t is less than 1, that means what happened? Uh, if this t is less than 1, or t greater than 0, x equal to 0. For x equal to 0, for if we put now x equal to 0, then this is 1 minus sine t. Okay, so this case is not also not happened. Okay, because there is no exponential form which is given, only exponential. This is 1. Fine. So this is not, we can discard these options also. Therefore only option which is remaining is that option 2, that does not exist any solution uxt of iv with that this is equal to this form. Fine. So means for x greater than t you get this types of solution, and for x less than t you get this types of solution according to the given initial condition. Fine. But there is no in between four options, there is no such answer that is actually answer. So therefore only remaining answer is not exist. Fine. So option 2 is correct here. So now the next question is based on steady state conditions. So for steady state, this actually question. So for steady state solution of equation, heat equation, you can see this lecture that is available on my YouTube channel, and this lecture is all based on wave equation. So this is an one short lecture series of wave equation. So by watching this video, actually you can cover all the portions of wave equations. I have covered all the theories and questions that generally asked in the CSIR net questions paper of wave equation. So you can also watch this lecture for wave equation. So I would like to make this one short lecture series for heat equation and Laplace equation if I get any request from you. Okay, so you can definitely watch this lecture. You got definitely help for your preparation. And this is the steady state solution of heat equation. You can also watch this lecture for the next question. The next question is based on in this concept. So this is the question. It says that let uxt be the solution of the partial differential equation, this one, satisfying the condition this and this, then which of the following is true? It is given that all the options are t tends to infinity. So t tends to infinity, what do you mean by that? These four, t tends to means infinity means this leads to steady state solution. Steady state solution. So in some in some recent previous years of CSIR net, this question based on steady state has recently asked. So this is very important concept for nowadays. So you can definitely watch my lectures for steady state solution. So what do you mean by actually steady state solution? Steady state solution means solution that is independent of time. Independent of time. Now here if u is the solution, then what happened? That means u is independent of time. That means here u t this is equal to 0. Fine. Del u del t equal to 0. U is constant of time. That means del u del t equal to 0. So now the question which is given here is that ut is equal to 16 u xx plus 2, this is equal to 0. Fine. So del u del t equal to 0 if we apply, then this means if we apply this thing, then this means 16 u xx plus 2, this is equal to 0. Fine. So u xx this is equal to minus 1 by 8. So if we integrate then we get ux equal to minus 1 by 8 x plus c1. Again, if we integrate, then we get uxt is equal to minus 1 by 8 x square plus c1 x plus c2. So this is the type, or this is the solution. Now note that this solution is a quadratic solution. That is, this solution is in the form, order of this solution is 2. Okay, this is a second order equation. Fine. Now it is given that in this solution, this is a fourth order, fourth order equation, fourth order in x. So this is in wrong. Now this is also, here the order of x is, degree of this equation is 3. Therefore this is also incorrect. And this option is only option which is the what which is the your second order equation. Fine. So this is actually a quadratic equation in x. So this is the correct answer. And for option A, you can say that uxt tends to 0. But for here it is given that if uxt x belongs to this, we are interested in non-trivial solution, not in trivial solution. But for x belongs to this one, if u tends to 0, this is only leads to trivial solution. Only leads to trivial solution, but we are not interested in trivial solution in any case. Also, you can note that this is already given. Fine. For each x belongs to 0 to 7, uxt is equal to 0. It is a condition which is given. This leads to trivial solution, which is not true. Fine. So option 4 is correct answer for this question. Next question. This is questions of non-homogeneous wave equation. Question says that let uxt be the solution of the initial value problem, this one, then which of the following is statement is true. Fine. So there are different kinds of method. Actually, you can solve this question. Here we apply the Laplace transform method. Laplace transform method. You can apply definitely different kinds of method. Here we apply the Laplace transform method. Fine. So what is given is that utt minus uxx, this is equal to e to the power minus t for x belongs to real and t greater than 0. Now apply Laplace transform. What we get actually? Laplace of utt minus Laplace of uxx, this is equal to Laplace of e to the power minus t. Now, what is the Laplace of these terms? The Laplace of this is, we all know that this gives, suppose s is the transformed variable. So s square u bar is the Laplace transform of u, s square u bar xs minus s u x0 minus u t x0. This is minus L of this is only differential because we applied the Laplace transform on the variable t. d2 over simple differentiation by dx square, this is equal to L of 1 minus it is over t, means 1 by s plus 1. Fine. So this is the transform, Laplace transform. If we apply now, put the value of this ux0 equal to cos x and utx0 equal to 0. So s square u bar minus s cos x minus 0 minus d2 u bar dx square is equal to 1 by s plus 1. So we can write d2 u bar dx square minus s square u bar. This is equal to minus s cos x minus 1 by s plus 1. Fine. Now this means, what do you mean? This means d square minus s square into u bar. This is equal to the same thing. So that means we write u bar equal to 1 by d square minus s square of minus s cos x minus 1 by s plus 1, and d stands for d dx. D stands for d dx. That means this operate only on x variable. S is treated as a constant here. So that means from here we can write u bar. This is equal to u bar equal to minus s and one we all know that cos x by minus 1 square minus s square, this is non-zero, so we can write this thing minus we can write 1 by s square into uh, minus s square into 1 minus d square by s square into 1 upon s plus 1. So this is equal to s by s square plus 1 cos x minus this minus goes to plus 1 by s square into s plus 1 into 1 minus d square by s square operate on 1 because these are independent of x. So now this is the case. So now if we apply inverse Laplace transformation, inverse Laplace transform, we get uxt on x. So this is the Laplace inverse of cos. So we know that, and this the variable is t. So this is cos t and cos x as a this, because इसके ऊपर तो अप्लाई नहीं हुआ, प्लस ये तो वैल्यू 1 ही होगा, प्लस L inverse of this one. We can write 1 by s square into s plus 1. Now this is we can do by this by partial fraction, fine. So if we do the partial fraction, this is a very basic thing of class 12. We can write 1 by s square into s plus 1. This is equal to a by s plus b by s square plus c by s plus 1. Now 1 equal to, you can write a s into s plus 1 plus b s plus 1 plus c into s square. Now in this identity, if we put s is equal to 0, s is equal to 0. If we put s equal to 0, then this term 0, this term 0, only this term. So b equal to, this implies b equal to 1. Now if we put s equal to minus 1, then this is 0, this is 0, and this is 1. This gives c equal to 1. Now equating the coefficient of s square, which gives 1 equal to a plus c. C is what? Mm, a s square bs, which actually gives, you can see that for equating coefficient of x square, a is equal to minus of 1. Fine. So we can write the solution that 1 by s square equal to, we can write 1 by s square into s plus 1. This is equal to minus 1 by s plus 1 by s square plus 1 by s plus 1. Now Laplace inverse of this inverse. This is equal to Laplace inverse of minus 1 upon s plus Laplace inverse of 1 upon s square plus Laplace inverse of 1 upon s plus 1, which is equal to minus 1 plus t plus e to the power minus t. So this is our inverse Laplace transformation. Now back to the question. Okay. So the question is what? Cos x cos t, right? Just I erase these things. Just a second. If we erase this thing, okay. So see, the answer is here uxt equal to cos t cos x minus 1 plus t plus e to the power minus t. So this is our solution. Now if we write the first one, that if we multiply this by e to the power minus t, so e to the power minus t cos e to u, here minus t into u, this is equal to what happened? So first term is see cos x and cos r, both the cos are bounded, e to the power minus t, e to the power t, sorry, not minus t, bounded minus e to the power t plus t e to the power t plus 1. See, this term goes to infinity. Fine, this term goes to infinity, therefore it says that it goes to 0. No, incorrect. Similarly, again in this, if t tends to infinity, fine, then what will happen if t tends to infinity? When this term goes to infinity, this term goes to 0, but not the complete, this is bounded, there is no problem with this condition, but this not goes to 0. Fine. Now option C says that there exists for each x naught greater than r, there exists t belongs to t naught greater than 0, such that u x naught t naught is greater or equal to 4. How can we see that? This option, so see, first term is bounded, and we all know that we can write that u x p, this is first term is bounded quantity, so, and we can write that this less equal to 1, so maximum value is 1, we can write. So this tends to equal to 1, nearly equal to minus 1 plus p and plus e to the power minus t is some fractional quantity. Okay, this is some, I can say, some constant, because e to the power, if e to the power minus t, then it will be suppose point something, point 1 or 2 or like that. Fine. So point, so this 1 and 1 goes to cancel, and this is only 1. So if we take t naught which is greater equal to 4, so t naught, if we take only t naught equal to 4 only, then this gives u x t gives 4 point something, this is equal to what, 4 point something. Fine. 4, just a second. So which is greater equal to 4 only. Fine, 4 point something which is greater equal to 4. So this is true, we can say, because of there exist, because of there exist. So we can say that option, we can say this option is true. But for similar case, this cannot happen, na? Less equal to 4 does not happen. So for these two options are same. See, 3 option and 4 options are same. So for t greater than t naught, so for t greater than t naught, because this is only t, so for t equal to this we can get this, but for t equal to t naught we cannot get this value less equal to 4. Therefore option 3 is correct here. So this is the solution of CSIR net December 2025, part B, partial differential equations questions. How was the solution? If this video is helpful for you, then definitely give a like to this video, share with your friends. Let me know in the comment section below how was the video or lecture. And okay, let's meet in another video. Okay, thank you, bye.